And here we are for part 2 of our fingerprint discussion. Alright, so it doesn't matter what term you use to make our fingerprints visible, development, enhancement, even visualization. It's all the same thing, it just depends on the background of the investigator. You'll find me sometimes using development because I have a background in photography and we develop film. So here's a weird, interesting little thing. Latent fingerprints can be found pretty much on any surface. And really we only find latent prints about 30 to 50% of the time at our crime scenes. A lot of the time we're not even looking for them, or we're not doing a very good job of looking for them. And how do we find them? Well, we use physical methods, chemical methods, special illumination. Typically what we do is a combined approach where we will use special illumination to help us find the prints, and then a chemical or physical method to make them visible for collection. Alright, so physical methods. We'll start off with the ones that most people are the ones that most people are knowledgeable about. Using powders to dust and lift the prints. Now, a couple different kinds of powders on the market. We have magnetic powders. We also have non-magnetic powders. Both of these are made out of inorganic material. Our non-magnetic powders are actually typically crushed up volcanic rock, so there is no living organisms in them. Our magnetic powders are some sort of ferrous metal that has been ground up into a fine particulate. Both have good applications. Really doesn't matter which one you use, although it does seem sometimes the magnetic ones are better on certain surfaces and the non-magnetic ones are better on others. Say like metal. The non-magnetic is better on metal versus the magnetic sometimes works good on like magazine print, on paper that is very glossy and doesn't absorb liquids. You can get some very good results with the magnetic powders. So, but both work on any surface. One thing you'll notice that sometimes when you look at these powders, there's lots of different colors. The big idea is getting a contrast between the surface you're trying to get the print off of and the powder that you're trying to use. So, look at like this gray cabinet I have behind me. Using a black powder on this, it might show up, but imagine like a bright fluorescent orange. That would show up really well. Maybe a white. So the colors help us with making prints more visible. The other thing that happens is you'll notice some of these, you can see it says like ultra red versus red. Ultras are ones that fluoresce, so when we use black lights at our crime scenes, we can see them better. So it makes the processing of the prints very easy. It also makes the photography of them a lot better if we get those ones that glow in the dark a little bit better with the black lights. Alright, chemical processing. Chemical processing is when we treat a product with some kind of chemical and there is a reaction to the chemical and that makes the fingerprint suddenly appear. The one that most people think about and that we'll talk about here is ninhydrin. There's a lot of other chemicals out there, DFO, Amidio black, a number of other ones that are out there that are usable. But ninhydrin is kind of a general purpose one that we think of as it relates to some of our crime scenes. And ninhydrin allows our amino acids to turn purple. And the amino acids are found in the sweat and the perspiration and some of the oils that we leave behind on the surface. So here we have like a check that has been passed and we treat it with ninhydrin and the fingerprints turn purple. So you can now see the fingerprints on the paper versus dusting and lifting a print from paper like this doesn't work so well. Because the fingerprint soaks down into the actual paper. It's porous. Now, the thing to remember about ninhydrin is you don't just use the ninhydrin. Ninhydrin is heat activated, so you have to treat the paper with ninhydrin, dry the paper, and then heat the paper. Being careful not to set the paper on fire because heat in paper tends to cause fire. Typically about 125 degrees is all you need. So I've literally used ninhydrin on a car dashboard where I put the ninhydrin on a product, let it air dry for a few minutes, threw it up on the dashboard of my squad car in the summertime, and within 15 minutes I had the fingerprints. That you usually want to do it a little slower, you want to do it at a lower temperature, but it reacts at a pretty decent temperature. And another chemical process that a lot of times folks have heard about is superglue fuming. And we've been using this since the mid-80s. We can use superglue in chambers where we can take and have a box and you put a little heating element in there. You put the superglue on the heating element, close the box up, turn on the heating element, and the superglue is vaporized. You can see here, these are some fingerprints on a plastic Ziploc bag, and they're right there. That's exactly what they look like. There's no fingerprint powder on them. The superglue has just adhered to them and made them visible. even on products that the fingerprints might not be as visible, say like on a pop can or a soda can, depending on what part of the state or country you're from. But if we take and super glue, say, a Pepsi or Coke can, you might not be able to see the prints, but now when we go and dust the prints with the physical methods, the chemical super glue keeps those prints locked in place, and it's harder to smudge them. So it makes our process a little easier. This little wand is a device. It's like a butane torch, and you've got super glue here in this cylinder. And so we can actually super glue fume at a crime scene, so we don't have to bring stuff back to our police department. We can super glue a door, a window, a section of wall or car right there at the crime scene. Do be careful of vapors. You want to wear a respirator. You want to have air mask on so that we're not breathing in those super glue fumes when using one of those wands. Special illumination, alternate light sources. Here we have an ALS system, and you wear these goggles. And when the ALS hits the fingerprint, it will begin to glow. Typically, we need to treat the fingerprint with a chemical first, so something like DFO or Ammonium black, and that will make the print glow. There are even little flashlight systems like this, where you've got the kind of the visor built in. And again, we don't pick this up with our natural human eye. It is the filters that help us see these. More than just using ALS for fingerprints, we can use it for blood and biological, fibers, hairs, bite marks, things that we'll talk about in future weeks. Sometimes it's as easy, though, too, is oblique lighting. If you've ever looked at a tabletop and you don't see any fingerprints, but then you kind of lean over to the side here and suddenly fingerprints are there, it's because the light is hitting them at a different angle and oblique lighting. So sometimes we just literally take a flashlight in the crime scene and shine it across tabletops, and we get lucky and we find some fingerprints. Typically, like I said, we use a combined approach. The combined approach will take and we use the ALS to find the prints. We use the chemical methods to set the prints in place with the superglue fuming, and then we go and dust and lift the prints. Remember, each step of the way we take a photograph. So everything you do, you take a photograph of. So you find the prints with ALS, photograph them under ALS. You treat it with a chemical, you photograph the surface. You then use ALS again to make them glow even better, and you take another photograph, and then you dust them, you take a photograph, then you lift them, you take a photograph. Every step of the way you take a photograph. So, how do we make these comparisons then? Well, again, as I mentioned in the first part of this video, first is classified out arch, loop, or whirl, and then we start matching them against other arch, loops, and whirls that are out there in our databases. And here we've got a section of a fingerprint from the crime scene. Here we've got a suspect's fingerprint from when they were booked into the jail, and we can see we've got these points of comparison, the delta here, we've got this little ridge that kind of terminates, we've got this little crossover, it's right there. So we've got a number of objects in this print that line up, and as you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 points of comparison just in this little section of the fingerprint alone. So just by that partial print, we've got 9 points of comparison. That's pretty much good enough for a fingerprint match. There are some debates as to how many points of comparison you need. Every lab has their own standard. We keep talking about a national standard. At the time of this recording, it has not been implemented. Now, how do we make these comparisons? A couple years ago, literally, we just had file cabinets filled with people's fingerprints. The drawers would be labeled arches, loops, and whirls, and you would literally just go through drawers and 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 drawers. And I'll keep saying that for the next 15 minutes, but I won't waste your time looking for a match. A very tedious job. Today we have our Automated Fingerprint Identification System, or AFIS. These days we even refer to it as IAFIS, the Integrated Automated Fingerprint Identification System. When the AFIS systems first came out, there were about 3 or 4 different people who invented them, and each person had their own file format, kind of like the old days where you had Mac and PC, and they didn't work with each other in any way, shape, or form. Now you can, take a Word document from one and go to the others because they've integrated. Same was true with AFIS. You had some AFIS devices that were developed using one kind of software, and another developed using another, and another using another, and there was no communication between them. So the FBI could only look at the FBI's fingerprints, the Appleton Police Departments could only look at the Appleton's fingerprints, and the Green Bay Police Department could only look at Green Bay's fingerprints. Now that we've upgraded and everybody has gone to IAFIS, supposedly everybody should be able to look at everybody else's fingerprints. Doesn't always work, but we're about 99% there. And really, we're lucky here in Wisconsin that everybody's kind of gone on board with some things that aren't kind of weird outlier software manufacturers. So everybody is able to communicate with everybody and the FBI here in Wisconsin, as far as I know. Now, we can load APHIS in on any desktop PC. It doesn't take anything special. A lot of your actual files is out on a server somewhere out, someplace like in Madison or in DC. We don't keep a lot of files locally. We do keep some files locally, but most of the heavy lifting is done out in the quote-unquote cloud. So what happens is you scan in a fingerprint, you find it at a crime scene, it checks against some of the local criminals who you keep in your local computer. If it doesn't make a match, then it connects to the computer in Madison. It checks against all of our state records. If it doesn't make a match, it then checks against the FBI's database out there in DC. So the process is actually pretty quick. If it finds a match locally, you can have a match in minutes. If we got to connect out to Madison, it might take a few extra minutes, and if you got to connect out to DC, it might take an hour or two. That's about it. It's actually pretty quick. The APHIS system, we have pattern recognition, and basically it looks at the data acquisition, arch, loop, or whirl, features, the bifurcations and whatnot, and then our decision making. Do keep this in mind that the computer does not make a match. The computer gives us a bunch of probables, and it's up to a human to make the final match. But what happened was, under the old system where we were going through the file cabinets looking for the fingerprints in the file paper, we were lucky to match about 1.5% of them. Today we match almost a quarter of our fingerprints. Now, the classification. We used to use a system here in the US called the Henry system. There's a couple other systems out there. The FBI created the NCIC FPC system, which is basically the Henry system, just adopted so that computers can understand it better. The Henry system was actually pretty easy. Classified fingerprints out based on the finger and the arch, loop, whirl, and it's an alphanumeric system. Very easy to learn. And so the FBI just adopted that in a system for our APHIS computers to be able to understand it. And that we call that the NCIC, which is National Crime Information Center, fingerprint classification. Now, the whole system that the crime lab uses is referred to as ACE-V, where we analyze the print, we compare it, we evaluate it, and we verify it. ACE-V was originally developed up in Canada. We saw that it was a pretty good system, and it is a system that provides for some good accuracy, where we, again, the computer is making the initial check, and then we are following up with it as human beings, saying, does this line up, does this line up, does this line up, does this line up, and to what degree of certainty are we sure that we have a match. All right, so that is fingerprinting in a nutshell. We have a whole class, impression evidence, where we get into all these topics so much deeper. This is just an overview in the intro class, so if you're interested, I would suggest that you take the impression evidence class later on in your schooling. Otherwise, this is a good primer on what fingerprint classification and fingerprint technology is. All right, anybody has any questions, always feel free. Email me, call me, stop into the Public Safety Training Center and see me in person. Otherwise, I will talk to you next week.